This conference will now be recorded.
Okay, guys, let us start today's session. So the last concept of our array, that is none other than the concept of priority queue, guys. That is the last concept that is left from the queue, not from array, but from queue. What is this? Priority queue. So what is priority queue, sir? What is priority queue? What is the definition, sir? Priority queue. Priority means, you know that. What do you mean by priority? Suppose, for example, in normal queue, what happens? Any element comes inserted at the rear end. Any element want to get deleted, want to delete it from the front end, sir. We never think about who is having more priority. But in priority queue, you cannot insert the element in the arbitrary fashion. You always have to give the priority to the element who is having more priority compared to the other. Suppose, for example, guys, only one chair is available. Now there, what is happening? More than one students are also there in that room. Now who will get that chair? All students are having same priority. Anyone of can get that chair, sir. I cannot say topper will get the chair. You are not having good marks, you are not going to get that chair. No, all our students now, they will get, one of them will get the chair because they're having equal priority. Suddenly a faculty came. Now students and faculty, only one chair is there. Who will get the chair? Sir, faculty will get the chair. Why? Because, sir, inside a classroom, faculty is having more priority compared to students. Because faculty is one level, sir, student is another level. So priority queue means a priority queue is a priority queue is a kind of queue a priority queue is a kind of queue in which each elements is assigned a priority. Each element is assigned a priority, and the order in which elements are deleted and processed comes from the following rules. What is that, sir? Rule number 1. In which order they will be deleted? An element, guys, with high priority, rather with highest priority, an element with highest priority is processed first before any element of lower priority. Every element is assigned with a priority. The element will be processed first before any element of lower priority. Next, sir, two are having same priority, then two or more elements with the same priority are processed according to the order they were added to queue. Oh, that means, sir, if the priorities are same, in that case first come first serve, na sir? Yes, if the priorities are same, in that case first come first serve. Two or more elements with same priority are processed according to the order they were added to the queue. That means whoever come first, he will be deleted first. But if it is having any high priority element, he will be deleted first, sir. So that is what you have to remember, because we are going to implement this concept with the help of programming also, this priority queue concept. But sir, in computer, where priority queue is used? In computer, priority queue is used for CPU scheduling algorithm. What is the terminology, guys? CPU scheduling algorithm. I told you at the very beginning stage of learning queue concept. So for CPU scheduling algorithm is a part of where this topic is available. It is actually part of operating system. In future, somewhere you learn operating system, there will learn CPU scheduling algorithm. Lot of CPU scheduling algorithm is there. One is called FCFS algorithm. That means first come first serve algorithm. One is called round robin algorithm. Another is called shortest job first algorithm. Like so many algorithms are there. Currently, that is not our topic of discussion. Just the one word, first come first serve, means you can understand. Round robin means actually, guys, suppose for example, here this is the process. Let us assume this is another process, right? Like we are having multiple processes, sir, not only two. We are having so many of them. We are having so many of them. We are having so many processes are there. And this is your CPU, guys. This is your CPU. Now everyone wants to get the CPU. Why? Because if he is not getting the CPU, how he will be processed? So what happened is that they came and forming a queue. They came and forming a queue. Now, if it is not priority queue, what will happen? Suppose you are implementing first come first serve, then automatically what will happen, sir? He will get the CPU totally served, then CPU will be free again. He will get the CPU. Done. He will be free again. CPU will be free again. He will get the CPU. First come first serve. Round robin says what? Round robin says what? For every process, I will be given 5 minutes of time. I will be giving you 5 minutes of time for everyone. Doesn't check who is having high priority, low priority, nothing. I will give everyone 5 minutes. Now, within that 5 minutes, if you can complete, within that 5 minutes, suppose he got the chance. This fellow got the chance. He got the CPU. Within the 5 minutes, if he can complete, then very, very good. He will be out. No, sir. He actually takes 10 minutes of time. He actually needs 10 minutes of time. But already you said, I will give the CPU for 5 minutes. And how he will complete? He will not be able to complete. So for to complete of the remaining 5 minutes, now the fellow have to come and wait at the end. Next fellow comes. I'm telling, oh, 5 minutes for you. Okay, sir. Within 3 minutes, he finished, gone. Next member got the chance. Within 2 minutes, he complete, gone. Another one. He takes 7 minutes, guys. What will happen? Within 5 minutes, not possible. Needs another 2 minutes. He will be waiting at the end again. He will be waiting at the end again. The remaining two fellows come. Sir, 1 minute he done, gone. Another fellow. 4 minutes, done. Next this fellow. He will again get the CPU. 5 minutes require. I will give you 5 minutes only. Complete, gone. This fellow require 2 minutes. Getting the chance, coming, doing, gone. Queue becomes empty. Understanding, guys, this is how it is normally followed in queue. That is called round robin. That means for everyone, a particular time limit is allocated. So that means, sir, where the priority queue concept is used. This is what I showed for normal process. But if anything like priority queue is mentioned among the all process, doesn't matter who comes first, who comes last, who come middle. If anyone comes who is having priority high, na. Suppose for example, guys. This is how they are standing. Suppose for example 4 process came, this is how they are standing. Suddenly one fellow comes with a bit high priority, boss, and when he come na, at that time, suppose this one got the CPU and working. Suddenly this high priority people came, then immediately what will happen? CPU will tell, okay, you wait few more minutes, I will see you later. You wait few more minutes, I will see you later. You will immediately take the high priority process first and will process. You will immediately take the high priority process first and will process. That is what is going to happen for what is called, sir, priority. Means if you are having priority related thing, the process who is having high priority, he will be processed fast compared to any process of having the low priority. So that means what, sir? Where it is used in computer implementation, in computer implementation, priority queue is used in CPU scheduling algorithm. At least basic idea of CPU scheduling algorithm you got. In details idea you will get when you learn the operating system, sir. These are not operating system, session, guys. Next and after that, so in computer implementation, priority key is used in the CPU scheduling algorithm, in which CPU need to process those processes which are having high priority, in which CPU need to process those processes which are having high priority, done. Last topic before we move to the programming of priority queue, that is, what are the different types of priority queues? Mention different design options, for priority queue. Different design option means what are the different types of priority queue is there? Very simple, guys. Two type of priority queue is there. One is called APQ, another is called DPQ. What is that APQ and DPQ, sir? APQ means ascending priority queue. DPQ means descending priority. Very simple. What is their definition? I will let you know. So there are two types of priority queue. Number one is ascending priority queue. Number two, descending priority queue. Ascending priority queue, descending priority queue. Sir, what is called ascending priority queue? Descending priority queue? Simple. First is ascending priority queue. First is APQ. So ascending priority queue is a priority queue ascending priority queue is a priority queue in which items can be inserted in which items can be inserted arbitrarily. Items can be inserted arbitrarily. But while deletion arbitrarily, items can be inserted arbitrarily, and while deletion, from which only the smallest element can be removed, that is called APQ. Insertion any order, but deletion smallest element means what, guys? Priority always means, remember one thing, low number means high priority. Understanding, guys? In your classroom, roll number 1, roll number 30, who is having high priority? Roll number 1 is having high priority, sir. Lower number represents high priority. Always, sir? No, not always. It's not always lower number represents high priority. In some cases, lower number represents high priority. Here we will consider that concept. Lower number represents high priority. That is what we are going to consider here. Understanding? Remember, lower number represents high priority. That is what we are going to consider here. So, smallest element can be represented means, oh, that means the high priority element will be removed, na sir? Yes. That means high priority element will be removed. That is called ascending priority queue, APQ. Similarly, we are having one more, last one, that is called DPQ. That is called DPQ, descending priority queue. Descending priority queue is a priority queue into which elements item elements all same, in which elements can be inserted, that is can be inserted or added, whatever, can be inserted arbitrarily, but while deletion, and from which element is going to be deleted, from which largest element, from which only the largest element can be removed. That means, oh, large number means, you said na sir, low number represents high priority, large number represents a low priority. Oh, that means low priority number will be deleted first, na sir? Yes. That's it, guys. That is all about priority queue. Now we will see this with the help of a program, sir. How can we do that? But before moving to the program, let me give one line note here regarding this priority. Low numbers represent high priority. Low number represents high priority. File, sir, save as. What is that? Priority queue. Yes, sir. Let's implement the program. Acha. For that, what we are going to do, first we need to copy the one queue application. Let me, anything while implementing priority queue, guys, it's your choice. You can go for linear queue approach, you can go for circular queue approach, it's your choice. So let it be keeping it simple. I'm taking the linear queue approach. Where is that linear queue coding, guys? L linked queue. Where is linear queue? What is the name? Queue with array. Queue with array. Linear queue only. Copy, sir. So this is going to be priority queue operations. Okay. Insertion, deletion, display. Just we will change the name here first. PQ. Control R. Replace. Replace Q with PQ. Replace. No. Cannot be done in this way. And this one will also be replaced. No problem. PQ, sir. PQ insert. PQ, sir. PQ delete. PQ front. PQI. Then PQ insert. PQ delete. PQ display. Your choice. You can have display name also. Just linear queue we are doing, guys. You can even implement with the help of circular queue also. But here deletion function I'm not going to touch. Deletion function I'm not going to touch, because we will insert in such a way, sir, so that always, let us assume we are implementing ascending priority queue, so that always the smallest element will be deleted. That means highest priority element will always always be at the first position. Highest priority element will always be at the first position. Highest priority means low number represents high priority. Okay. Suppose, guys, you run the application. It is asking enter the item to be insert. You call this PQ insert with 10. Control comes here. Is rear is equal to max minus 1? Let us assume rear value, max value is 5. No. Is front minus 1? Yes. Front and rear is 0. Insert the first element, guys. Suppose first element got inserted. What is that? 10. 10 is currently there in the queue. At which index, sir? 0th index. Currently front and rear value is what, guys? Both have been incremented now for first insertion. For first insertion, both get incremented, guys. You know that. So currently, if I ask, what is the value of front and rear? What is the answer? Sir, both are 0. Super. And in your queue, how many element is there? 10. Only one element is there. Listen, guys. First time insertion, no problem, sir. Everything is happening perfectly. Second time you insert, guys. You call the insert. This time what happens? 5 came. Is rear is max minus 1? No. Front minus 1? No. Rear plus plus PQ rear item. Rear plus plus PQ rear item. What you did? You will inserting as per the coding 5 here. Tell me, guys, what you said? You said that, sir, it's a priority queue. Currently rear value is what? 1. And you said that what? It's a priority queue. Priority queue means what? Sir, low number represents high priority. High priority element will be deleted first. Now you said that. Ascending priority queue means smallest element will be removed. Smallest element removed means high priority element. So now if you insert 5 here, guys, if you insert 5 here and remain silent, problem will be when removal will come na, removal will take place from which end? Front end. 10 will be deleted na sir. If 10 is deleted, where is your ascending priority queue concept? You said na smallest element can be removed. Now the largest element you are removing. So what you need to do, guys, you need to interchange 5 and 10 so that now your content looks like 510. The content looks like 510. Understanding my statement, guys? Now if you go for removal na, see, smallest element will be removed na from the front. Yes sir. You call insert function one more time, sir. For that I have to write the logic na sir. Yes, you have to write the logic. Where after this? Okay, we will write that. Let's practice few more. Sir, now suddenly 3 came, sir. 3 came. What you did? Sir, I inserted here. Is it okay? No. Or say guys, say 7 came. Not 3, 7 came. What you will do? Will you remain silent by inserting 7 here? No. Then will you bring fast? No, sir. Then, sir, in the middle I will bring. In the middle I will bring. Okay. Then how it will happen? 7 came. First what will happen? Sir, 5 and 7 will be compared. Is 5 is more than 7? No. Next, 10 and 7 will be compared. Is 10 is more than 7? Yes. Then what will happen? Sir, I will have 10 here and then I will have 7 here. So that means how it will look like 5, 7, 10. Now if you go for deletion operation, always the element which are lesser will be removed now. That means what? High priority element will be removed now. You said that low number represents high priority. High priority number will be removed. But then sir, how I will implement the code? Tell me after the insertion, what is called real value? 2 na guys. The real value is 2 na. When sir real value is 2? After I insert 10. This is current configuration after swapping. But when you inserted, how it was looking like? Sir, 5 was here, 10 is here, 7 is here. Like that is the situation. When I swapped, then I got that. That's a different story. But this is the current situation. If this is the current situation, your range is how far? Sir, my range is here to here. Oh, that means from front to rear, na? Yes, sir, front to rear. My range is 0 to 2. 0 to 2 means, check it out, front value. Check it out, front value 0, rear value 2. So my range is 0 to 2. My range is 0 to 2, sir. Okay, let's take another example. Then we will go. Let's say another value because we need a bit lengthy array. This is 5, 10, 7. Red one means after insertion it was looking like, and black one means after swapping operation it is looking like. Similarly here, let's do like this. After swapping it looks like this, 5, 10. 5, 10. But after insertion, how it is looking like, sir? 10, 5. Understanding? So red one is after insertion. Just when you insert, that is how it looks like. And black one is after swapping. Suddenly 5, 7, 10. Suddenly what happens? One fellow came with the value 3. Then how it will look like? 10, 3. Will you remain silent? by keeping 3 there? No. Then what you are going to do, observe here, because from here we are going to develop the coding. See how beautiful is this, guys. Sir, this is in the array. Okay. How many cells are there, guys? 4. Actually 5 cells, but currently I'm having 4 elements, sir. That's why focusing on 4. You can go for another element and then you can also do that. No issue. So what is your current? Just this element is inserted. So that means, sir, my current real value is basically 3. That is my current real value. Super. So this is, sir, front 0. This is rear, sir, 3. Front is pointing here, rear is pointing here. One more cell is left. One more cell is left though. I didn't insert the element yet. I may insert also, not an issue. Currently I inserted 4 elements. One more cell is there, sir, as per the max value is concerned. As per the max value is concerned. Now, how I will develop the code? Let me tell you what I will do. Sir, first I will take 5 and I will compare 5 with 7. Is 5 is more than 7? No. Interchange take place? No. Then 5 versus 10. Is 5 is more than 10? No. Interchange take place? No. Is 5 is more than 3? Yes. Interchange take place? Yes. That means how it will look like? Sir, it will be looking like this. Three here, sir. 3. I'm writing this with a color change to give you the indication that swapping happened. 3 will be coming here and then 5 will be coming here. Next, which element I will take, guys? 7. 7 and 10 I will compare. Is 7 more than 10? No. Is 7 more than 5? Yes. Means what? Sir, change. Which two? 5 and 7. 5 and 7. I'm making it pink to indicate that swapping takes place. So after 5 we will do it for whom? Sir, after 5 I will do it for 10. What activity? Sir, this 10 I will check it for whom? With 7. Is it more? Yes. Sir, change. Change means what? Swapping. Who will be coming here? 7. Who will be there? Array 7. Who will be there? 10. Now you are feeling very happy with this content, guys, because whenever you will delete now, see the smallest element will be deleted. 3. After that, next smallest 5. Next smallest 7. Next smallest 10. Then what is the logic I'm going to write here? You remember, guys, let me show you again from the beginning. This is the condition, guys. This is the condition. Then what I am doing, see, I made compare 5 with 7, 10, 3. Next, which element I took? 7. Compared with next. Then which element I took? 10. Compared with next element. So that means for which index element I made comparison, guys? Sir, you started making the comparison from 0th index element, that is 5. After that, 5 compared with everyone. Let me write code for that. For I is equal to 0. I0 indicates what, guys? Sir, 0th index element. Who is the 0th index element? 5. Who is the 0th index element, guys? 5, sir. Super. 1 minute. Yeah. Who is the 0th index element, sir? 5. zeroth index element, next time you will compare which index element? 1th, I plus plus. After that, second. After that, no more, sir. Because third index element is no one having to compare. Third index element is no one having to compare. So what I can write here, sir, I is equal to 0, na? 0 is a hard code value. You cannot give hard code value. Front I am giving. How far, sir? How far? I will be moving how far? Up to 0, 1, 2. It will not go to 3 because third index element to its right, it is not having anyone to compare. So I is equal to front, I less than rear. Rear value is 3 na. Then I will go how far? Up to 2, sir. Now see here. You see here. When I first time, guys, I is equal to 0. Then the 0th index element will be compared with whom? Sir, 1th index element, 2nd index element, 3rd index element. Doing the work repeatedly na. Comparison with 1th index, 2nd index, 3rd index. Doing the work repeatedly na, boss. Sir, another loop will be required. Another loop will be required for j is equal to. Can anyone tell me, sir, j will start from where, guys? This element I will start comparing with this. Can anyone tell me the j value, guys? Initialization value of j. Or even it is the wrong answer, no need to worry. You give me the answer. Sir, from j will start. Whatever your mind is saying, you just write that. See, Aniket, if you write j is I na, that means what? The 0th index element will be compared with 0th index element, but it is happening. Or the 5 is started comparing with 1th index element, 2nd index element, 3rd index element. Is I'm comparing 5 with 5? No, sir. I'm comparing with what? 1th index element, 2nd index element, 3rd index element. So that means what? Sir, the j value will become, you got it on Aniket, you got it now. What it is going to happen? Sir, the j value will become I plus 1. J value will become I plus 1. So automatically you can understand that now. What is the j value, guys? 1. Oh, 0th index element and 1th index element will be compared na, sir? Yes. How far j will go? Sir, j will go up to the rear because j will go up to the 3rd index. So j will go up to the rear. J plus plus. Super. Now what you are checking when you are comparing? Oh, tell me what is 0th index element? 5. What is the 1th index element? 7. We will compare na? Yes. How will write? Sir, PQI. Oi, PQI means I is 0, then PQ0 is 5. Is 5 greater than PQJ? Is 5 greater than PQJ? J is what, sir? Oh, PQJ. PQJ is what, sir? Here, which element you are comparing basically? 5 is greater than 7? No. It will enter in this if? No. Then end of second for. End of second for. Code comebacks here. J will be incremented. J value will become 2. Now which 2 will compare? Sir, 0th index element and 2nd index element. That means what? 10. 5 greater than 10, guys? No. If block will enter 10? No. Second for loop. That is the inner for loop. So let me give a bracket here. Comment line bracket is not seen here. Inner for loop, sir. Inner for loop. Loop rotates. J becomes 3. PQI 5 greater than PQJ. J is 3. PQJ means PQ3. What is that? 3. Is 5 greater than 3? Yes, 5 greater than 3. What to do? Sir, swap, sir, swap. Swapping logic I am not going to make you understand. From your childhood you know that. Sir, temp is equal to PQI super PQI is equal to PQJ and PQJ is equal to temp. PQJ is equal to temp. Sir, what will happen, sir? In this if block, sir, 5 and 7, 5 and 3 got interchanged, sir. 5 and 3 got interchanged. Super. Sir, you know loop rotates. J becomes 4. Is this loop is going to entertain anymore, guys? J is 4. Real value is what? You forget real value was. Real value is what? 3 na, guys. Real value is what? 3. J value becomes 4. Is 4 greater than, is 4 less than 3? Is 4 less than 3, sir? No, na, boss. J value is 4. Real value is 3. 4 less or equal to 3? No. Inner for loop will entertain? No, sir. Now outer for loop. Now outer for loop. Where is outer for loop, sir? This is outer for loop. This is outer for loop. Super. So let me arrange the brackets perfectly. This is if inner for outer for. Yeah. Now the control goes to outer for loop. I value will become what, guys? 1. J value will be starting from where? 2. Then which two will compare? Sir, 7 and 10. Check it out. PQI. I means 1. PQ1 means 7, sir. PQJ. J is 2. 10, sir. Is 7 greater than 10, guys? No. Comparison will, swapping will take place? No. Next, if is not entertained, inner for. J becomes 3, sir. Feel 3 less or equal to rear? Yes, rear 3. 3 less or equal to rear? Yes. PQI. Sir, I is 1. PQ1 means 7. PQJ. J is what? 3. PQ3 is what? 5. 7 greater than 5, sir? Yes. Swapping will take place? Yes, sir. Swapping will take place? Yes, sir. Swapping will take place, guys. Okay, let me do it manually. Not working. Control Y, Control Z, Control Y, Control Y. Okay, no, not working. No problem, sir. Which two will be compared? 7 and 5 will be swapped. 7 gone from here will come here. So now it will become 5 and 7 respectively. Next time, sir, if block done, inner for loop, J becomes 4. Will it enter anymore, guys? 4 less or equal to 3? No. Then, sir, outer for loop. Outer for loop means, sir, now I become 2. Next, then J will be starting from where? 3. So now for which element, sir? 10. Which element? 10. Come here. PQI. What is that? 10. PQI was what? 10. Greater than PQJ. What is that? 7. 10 greater than 7? Yes, sir. Swapping will take place? Yes, sir. Do swapping. Do the swapping. 10 gone. 7 gone. 7 here. 10 here. Done. Swapping done. If done, inner for loop rotates, J become 4. 4 less or equal to 3, guys? No, sir. Will it entertain anymore? No, sir. Outer for loop. Sir, I becomes 3. Once I becomes 3, check it out here. 3 less than 3. Will it entertain? No. Will it enter in the outer for loop? No. Then where you are standing? Outside of the for loop. You are happy now, guys? Because now it is beautifully framing like 3, 5, 7, 10. Now if I go for deletion, smallest element will be deleted only. Understanding, guys? Everyone got clarity, sir? How the priority queue is working? This bracket is extra. Now just go for running the application once. Execute, compile and run. So here anything is uncommented, guys. Acha, ij is not declared. Let me declare it. Int I, comma j. Okay, sir. Execute, compile and run. Next, what it is telling? It's a spelling mistake. P-Q-U-E-U-E. Okay. Execute, compile and run. Achha, temp is not declared, sir. PQ is an integer array. So temp is an integer variable. Declare that temp. Third variable. Execute, compile and run. No error, no warning. We will do this order of insertion, guys. What is that, sir? Remember the order? First who came? 10. Next 5. Next 7. Next 3. Let's do that. Enter your choice. 10. Display only 10. Next, enter your choice. Who will be inserted, guys? 5. Now if you go for a display, what thing it should show, guys? Respond in the chat box. Now if I go for a display, in which order it should display, guys? After insertion of 5, in which order it should display? 5, 10. Super. Okay now, boss. 5, 10. Sir, insertion. Insert element 7. Now if you go for display, sir, 5, 7, 10. Check it out. Array. Excellent. Next, sir, one more time. Sir, 3. Next, display. How it should display, sir? 3, 5, 7, 10. Super. 3, 5, 7, 10. Deletion algorithm, are you going to make any change? No, sir. Deletion, why should I change? I have arranged in that way in my insertion. Now, if you go for deletion, sir, largest high priority element will be deleted. Who is high priority element? The element with lowest number is high priority. Then who will be deleted? Sir, 3 will be deleted. Really, sir? Check it out. Deleted element is 3. Now Q is having 5, 7, 10. 5, 7, 10. Again deletion. Who will be deleted? 5. Element 7, 10. Next who will be deleted? 7. Element 10 only. Now who will be deleted? 10. Now if you go for display, sir, Q empty. Enjoy priority queue, guys. File, sir. Save as. That is, sir, end of our queue concept. Tomorrow when we'll meet, guys. Acha, I'm deleting this, or I should keep this one, guys. This example, it should be there in the note, or I should delete this part. Should I keep it or I should delete it? Respond once, guys, in the chat box. This part is needed, or I should delete this? Keep it, sir. Okay, no problem. Acha, tomorrow when we'll meet, guys, we will start another concept that is called, so what we have completed in details are in data structure, stack, not even a single point we left, queue in details, linked list in details, recursion in details. Tomorrow when will come, tomorrow probably we are not going to develop any programming. Tomorrow mostly we are going to learn theoretical thing, and application we are going to practice tomorrow. Tomorrow coding will not be there. So tomorrow and after that you will get 2 days. So by the in the meantime, in these 3 days, what your target is just to revise recursion and dynamic memory allocation, because in tree, while programming, these two concepts will be used frequently. And at that time, if you are not having the revision of recursion and dynamic memory allocation in linked list we have done so many times, so very easily we'll capture that. But recursion you might forget, because it may be almost 2 months back we have done that recursion. So just make sure you revise that recursion, because entire tree is based on recursion. Entire tree is based on recursion. So that is why before attending tomorrow's session, compulsory you have to revise the recursion. Otherwise you will not understand tree concept, guys. Okay. Thank you, students.